Elon Musk just unveiled a new movie in which the Tesla Humanoid Robot Optimus does amazing dance routines, astounds onlookers with its coordination and grace. Since its initial release in 2021, Optimus has advanced significantly. The robot was upgraded to the Gen 2 version by 2025, which has improved movement and balance, as well as the capacity to carry out challenging jobs like cooking and object sorting. More than merely amusement, the Optimus dance showcases advancements in mechanics and artificial intelligence. Reinforcement learning was used to teach the robot in a virtual environment, enabling it to acquire intricate movements and adjust to the real world. With the possibility of scaling manufacturing in 2026, Tesla intends to start producing Optimus in limited quantities in 2025. According to Elon Musk, these robots could be crucial in automating repetitive chores, enhancing people's quality of life, and increasing productivity in a variety of sectors. But Optimus is by no means the only advanced humanoid developed in the US. Boston Dynamics' Atlas, one of the most recognizable and iconic robots of our time, is part of the same technical pantheon. If Optimus represents elegance, fluidity, and synchronized collaboration with humans, then Atlas embodies power, dynamism, and endurance in extreme conditions. Atlas runs, balances on one leg, crawls, climbs over obstacles, and instantly adapts to changing environmental conditions. This is no longer just a demonstration of movement. It's a test of physical autonomy and resilience pushed to the edge of what's possible. Thanks to reinforcement learning algorithms and a vast array of sensors, the robot operates as a fully autonomous agent in complex environments, rather than a pre-programmed machine. Unlike Tesla Optimus, which is designed for everyday human interaction, from logistics to household assistance, Atlas serves as a research platform, refining the art of motion, mechanics, and robotic adaptation to unstable or even destroyed infrastructures. A new bionic robot named Nuo has been unveiled by the Beijing-based startup Nutix Robotics. This robot is equipped with 32 degrees of freedom, providing highly realistic facial expressions and body movements. Thanks to built-in actuators, sensors, and artificial intelligence systems, Nuo is capable of holding natural conversations, recognizing emotions, and responding to gestures and tone of voice. The robot can be used as an interactive guide, educational assistant, or in service and medical fields. The model features a customizable appearance, including makeup, glasses, and hairstyles, and its behavior adapts to various usage scenarios. Its face precisely mimics facial expressions, lip movements, and blinking, while its voice sounds natural thanks to integrated voice AI. The base model is priced at approximately $5,625. The CL3 humanoid robot from Chinese company Lynx Dynamics has learned to perform complex stretching exercises, showcasing remarkable flexibility and balance. In a recent demonstration, it performs movements reminiscent of an evening workout, raising its arms, twisting its torso, doing deep squats and side bends. Standing about 164 centimeters tall and weighing 50 kilograms, the CL3 is equipped with high-torque hollow actuators, which provide a high torque density and enable full-body balance across a wide range of motions. The robot's control system integrates environmental perception, motion planning, and real-time control. In addition to stretching, CL3 can get up from the ground after a fall, confidently navigate uneven terrain, climb steps and inclines, and maintain stability under external forces. Next up is China once again. This time, the company Unix AI has unveiled a new version of its humanoid robot, Wanda 2.0, which is now available for order starting at 88,000 yuan, approximately $12,200. Wanda 2.0 is a full-size multipurpose robot with a wheeled base designed for household, office, and retail tasks. It stands at 170 centimeters tall, adjustable down to 140 centimeters, can carry up to 6 kilograms per arm, and moves at speeds of up to 1 meter per second. Thanks to its high-density removable battery, Wanda 2.0 can operate continuously for up to 16 hours and remain in standby mode for up to 30 hours. One of the key upgrades is the addition of 8-joint bionic arms, an improvement over the 7-joint arms in the previous version, enabling smoother and more precise movements. The robot is equipped with adaptive 2-finger grippers, with positioning accuracy of up to 2 millimeters, allowing it to perform complex tasks, such as dart throwing or archery. You're looking at one of the most unusual robots of our time, Orinheim Echo, a telepresence bartender created by the Japanese company Oralab. At first glance, it may seem like just a robot with arms, a camera, and a display. But in reality, behind its movements, voice, and actions is a real person. Someone who physically cannot be at the workplace, yet still takes part in society. Orinheim Echo is part of a larger project aimed at integrating people with disabilities into active employment. The robot is operated remotely. The operator sees guests through cameras, hears them via microphones, speaks through the robot speakers, and moves its arms, serving drinks, pouring coffee, handing over glasses. The robot becomes the body of a person who may be in their apartment, a hospital, or even another city. But thanks to this technology, they can fully work as a bartender. This project is not just about a robotic bartender. It's a revolution in the concept of employment, inclusivity, and the future of social robotics. This is OpenARM, a unique open-source robotic arm with full telemetry and feedback, developed by Reason Human Interaction Lab. What makes this system exceptional is that the human operator doesn't just control the arm. They can literally feel what the robot feels, responding to object resistance in real time. This fundamentally changes the approach to interaction. For the first time, we're seeing a platform where telepresence is no longer a simulation, but almost a physical extension of the human body. The robot performs delicate manipulations, adapts to load, and its URDF model is synchronized with the simulation so precisely that training, debugging, and even AI experiments can be conducted in a virtual environment before deploying the model in the real world. At the same time, the entire structure is modular, open source, and built from accessible components. Projects like OpenARM prove one thing: the future of robotics doesn't have to be built in billion-dollar corporate headquarters. Engineers at Loki Robotics have unveiled one of the most practical robots to date, the Loki Autonomous Cleaner, designed to replace human cleaning staff and deliver consistently high-quality cleaning with minimal costs. This intelligent robot navigates buildings independently, opens doors, and adapts to various types of flooring and room layouts. Cleaning costs can be cut by as much as 50% using Loki, while still keeping a constantly high level of cleanliness. It weighs only 30 kilograms, has a cleaning capacity of up to 557 square meters per hour, can run for up to 3 hours on a single charge, and can go up to 1.8 kilometers per hour. The robot can prevent mishaps by detecting barriers, humans, glass walls, and even staircases thanks to its extensive array of sensors and cameras. Which robot from this video did you like best? Let us know in the comments. Remember to subscribe to our channel and like this video. View our earlier videos as well. Farewell.